You are on, sir.
All right, so the class today is on intermediate color mixing. Most of you have done some color mixing sometime in the past, maybe in the elementary years, but this will just sort of expand on what you've already been taught and teach you a little bit more about color mixing. So who can tell me what the three primary colors are?
Oh!
Yeah, give me one.
Red.
Yes, red. Someone else give me another? Yeah, purple.
Blue.
Blue.
Yellow.
No class answers, Laura.
What?
Said no class answers. Raise your hand.
What are the rules?
So who can tell me what the secondary colors are? Yeah, give me one.
Green.
Green,
Orange.
orange,
Purple.
and purple. So what two colors do you mix together to get green?
Yellow and blue.
Yellow and blue.
Sorry.
So green,
It's okay.
red and blue makes purple, and yellow and red makes orange. So we're going to try out mixing yellow and blue to make green. So everyone agrees that that's blue and that's yellow. So when you're mixing paint, always put dark into light. And that's pretty much what you get. So I'll just hold it up, it might be a little bit easier to see. So that's the color that we got by mixing yellow and blue together. How would you describe that shade of green?
Forest.
Forest, how vibrant is it?
Could be more vibrant.
Yeah, it's a little bit definitely on the dull side. So that's pretty much what we're looking at. You've been taught in the past that yellow and blue make green, and that's actually just one color theory. So that color theory is actually called the red, blue, yellow color theory.
Wonder why.
And that's the red, yellow, blue model right there. So you can see the red, the blue, and the yellow go together, and you can see the orange, the purple, and the green. And supposedly, if you mix all three colors together, you get black. But this is just one color model, and that's all it is. It's a model. It's not something that's based on the physical properties of color. So another color theory, can anyone tell me what colors they typically use for printing, like in a newspaper or other types of print media?
Black, black, and white.
Black is definitely one of them, yes. But when you see like a print, and sometimes you can see the dots on the side of a newspaper, are they these shades of red, or are they slightly different?
Like a magenta.
Yeah.
Yeah, exactly. So for print media, they realized that using what are called intermediate colors, you don't have, there's some gaps in that color field. There's some colors that can't be reproduced. So in print media, they actually use something called the CMYK model. So you have magenta, yellow, and cyan, and all three together form black. So the purpose of doing this is by shifting the colors a little bit they are able to reproduce more colors than the 3 colors that you learn in the red, yellow, blue model.
Our personal printers have those.
Yeah,
Or
exactly.
just-
That's a form of print media. So your inkjet printers, those are the 3 colors that they have in the inkjet printer. So when you're actually printing, it lays down each color on top of each other so that you actually achieve a full color image. So this brings me into something called color space. Can anyone actually tell me another color theory or another way of mixing colors that is commonly used? Like on a projector, what colors are used in a VGA monitor, a color TV, a projector? Anyone know? It's red, green, blue.
Yeah.
So when we're working on the colors for our websites in Andrew's class, when you customize your colors, those are the 3 colors that you play with: red, green, and blue. Oh, go one over. So the red, green, blue. This is slightly different because it's called additive color instead of subtractive color. When you use light, colors are added to make white instead of added to make black. So red, green, blue, those are the colors that you get by mixing them. And this is the last thing that I really want to touch on. This graph represents what colors the human eye can actually perceive. And that's actually called lab space in color theory. So whatever's in that graph, in this entire curve, that's everything that you can perceive with your human eye. With red, green, blue, which is a very, very good color theory and encompasses a lot of color, this is the part of the graph that you can actually replicate on a computer monitor. So everything up here, more vibrant greens, more vibrant blues, more vibrant reds, that grayed area is everything that cannot be replicated on a red, green, blue monitor.
Wow, I did not know.
So that's the visible spectrum. And the problem with displaying a visible spectrum on a monitor is that if there are any gaps, the monitor can't produce them. And it's easier to look at the gaps if we go to back to the CMYK color monitor. So that's the biggest thing that you have to keep in mind is these ways of mixing color, they're based on how our eye perceives color, not on the physical properties of light. We have 3 different types of cells in our eyes, and they're able to detect intensity of certain colors. So when we mix colors using three main colors, we're trying to tap into the physiology of our eye, not into something that's based on actual properties of light. So red, green, blue, like I said, is a very good way of mixing color. The CMYK, that, remember, is what's commonly used in print media. So in printing newspapers, in printing etchings, in color copiers. And you can see them compared side by side. What do you notice about the CMYK model?
Darker, duller.
Yeah, a lot of colors are duller. Red isn't so bad, but the green isn't so great. The blue, magenta's all right. What colors do you see that are hard to replicate then? The oranges and the greens themselves. So actually, you can buy you can buy specific print cartridges if you're printing a lot of pictures for your inkjet printer, and those typically use something that's called hexachrome, and they add two new colors. So they specifically add a green, so you can actually produce vibrant greens, and they add an orange. So for painting, because of the, we talked already, if you just use a straight yellow and blue, you have trouble producing those same colors, orange and green. For painting, they've devised another system, and that's the warm-cold method. So instead of just having one blue, in my paint box, for instance, I would have two. So that's a purple biased blue. Try and find that. This is a more green biased blue. So when you're painting, typically when you're developing a paint set, you would buy two of each primary color with a bias as opposed to just one. So for blue, you would have a purple biased blue, and then a green biased. And you just would not buy a neutral color like that. You would just buy the purple biased and the green biased. The same with the yellow. You would buy a green biased and you'd buy an orange biased. Same with red. You'd buy a purple biased red, and then you'd buy a more orange biased red. So at this time, I'll hand out the group activity. You're obviously not going to have much time to work with it, so I'll just show you basically what I have prepared. So the sheets that I hand out, they have 3 columns. So 2 of the columns on either side are the primary colors. And the middle is where you actually mix your colors. So the first 3, I would use, or the class activity would be to use the colors that are biased furthest away from the color you want to produce. So for green, to produce, I want first to show you a muddy color, a purple biased green, and an orange biased yellow. Mix those together and see what color green you get. And then use the actual yellow biased, the green biased yellow and the green biased blue and see what color you would achieve with that. So obviously we're pressed for time, but I would hand these out, and then you would mix. You would mix the 6 different colors. So you'd have one. The first stage would appear fairly muddy, and then the second one should appear to be more vibrant. So after we would produce the colors, we would actually look at them as a class, and then, I mean, what have we learned so far in this class?
There's more than one way to mix a color.
Yes, exactly. And that our ways of mixing colors, they're not based on the physical properties of light. When you pass light through a spectrum, you get every color in the rainbow. It doesn't break it down into secondary colors and then into primary colors. Each spectrum of light has a specific wavelength. It's not made up of other light except for white itself. So when you're mixing colors, that's based on the physiology of your eyes, not on the properties of light itself. And when you're mixing colors, the red, blue, yellow is the simplest model that you learn in school. But just keep in mind that if you want vibrant colors, or if you want to match specific colors, you may have to use a color theory that's slightly more complex.
Thank you.